So in this video we're going to learn about the last part, which is called the altitude, and we'll be using the altitude a lot when we talk about area, and I'll explain why. So you can draw and identify the altitudes of triangles and know and apply theorems about the altitudes of triangles, and can state and find the orthocenter, so this is our final term for centers of a triangle. Each one has its own center name because it has a different purpose. So the altitude is a segment line or array that is perpendicular to the opposite side of the triangle. Now, the big main part is that it has to go through a vertex of a triangle. Alright, so if I want to draw the altitude of these triangles, it has to go through the vertex, and then it has to be 90 degrees to the opposite side. So that right there is an altitude. Now there's a total of 3 altitudes in every triangle because there's one for each vertice, and sometimes the altitudes may not actually be inside the triangle. So let me show you what I mean with Sketchpad. Let's see if I can find... Yep, so this one right here, these are my altitudes. So how I constructed them is that, notice each one is going through the vertices, and then if I would measure these angles, they are at 90 degrees. So right now, notice it is a acute triangle. All 3 angles are acute, and then the point of where they intersect, called the orthocenter, is in the middle. Now let's make this triangle right. So right now I have a right triangle. Notice my orthocenter where they intersect is actually on one of the vertices. And notice 2 of the altitudes, that one and that one, are actually on the triangle. They're not inside the triangle like when we had it be acute here. Okay. And then the last one, we're going to make this obtuse. I now have an obtuse triangle. So notice we have 1 altitude that's in the middle, and then we have 2 of them. They intersect on the outside of the triangle, and then your circumcenter is on the outside. So altitudes, up to this point, everything has been inside the triangle, everything you've drawn. However, altitudes sometimes can be on the outside. Right. And again, the reason you can kind of think of it, I wish I could make this line dash, but let's change the color of this. So, reason why it's an altitude is that we can extend each side, like so. And so that's where you're getting the perpendicular. For it to become perpendicular to the opposite side, it needs to intersect on the outside. Very similar with a right triangle. Delete that. Delete that. We don't need that anymore. Those points. If I make this a right triangle, being perpendicular to the opposite side, well, this is a right triangle. It's already a right angle, so that's why the altitudes are on the side. Alright, reason why we're going to be using this a lot is that the altitude, you are more familiar with it, calling it the height of the triangle. And if you remember the area formula triangle, 1/2 base times height, you're going to use the height. The height is the altitude. So really, we could have taught you 1/2 base times the altitude. Alright, so again, the orthocenter is a point of concurrency, but the altitudes, there's no really theorems that deal with the orthocenter. There's something more advanced when you get into higher level geometry, what happens, and if you're really curious, I can show you in class. But again, the orthocenter can happen in, on, or outside the triangle. And notice where the altitudes are on each of these. Sometimes they're on, sometimes they are on the outside, and sometimes they're all in. And then between different sections is where, or different types of triangles, where your orthocenter is actually going to intersect. Alright, so reveal the altitude is the height of the triangle, which is something you're a little more familiar with. So it needs to go through a vertex and needs to be perpendicular on the outside. And remember, sometimes they can be on the triangle, these altitudes, and sometimes they're going to be on the outside. There's at least one that's always inside, but the other 2 can change. And the orthocenter, which is the point of concurrency, where the altitude can happen inside the triangle, outside the triangle, or on the triangle. Reminder to do a reflection so you get credit for watching this video.